Hey everyone, today we're going to be solving this problem that is asking us to find the charge density using a given electric field. So the first thing that we're going to have to do is we're going to have to find an equation that relates charge density and electric field. So we have one using the differential form of Gauss's law. So when we rewrite the terms in the equation, we find that the charge density is equal to epsilon naught times the divergence of the electric field. So all I'm doing here is I'm replacing the electric field with the electric field that they give us, just so it's easier to, visualize. And I'm going to take out K from the electric field since it's just a constant and we don't have to take the divergence of K. So I'm just taking it out. And the last thing I'm going to do here is I'm just going to multiply out the 1 over r that we're left with so that it's easier to take the divergence later on. So I'm just rewriting the whole equation here. Right. And so since we know that these are spherical coordinates, we're going to have to use the spherical terms for the divergence. So I'm using different colors here so that's easier to visualize what I'm doing. I'm just writing out the divergence using spherical coordinates. And I'm going to circle the terms in different colors in a moment so that you can see where they go. If you guys haven't noticed yet, this is actually a voiceover of me solving the problem. The reason is that it took me around 20 minutes to actually write out this whole problem, and that was way too long for a video. So I'm just going to voice over and fill in on any parts that might seem confusing in the video, so that way it's not a 20-minute long video. So what I'm going to do is I'm going to solve each term one by one. So first up, we're going to do the E sub r term. Right, so I'm just going to copy and paste that part. We're going to replace the E sub r with the actual r component right here. And we're just going to solve. So cancel out the r's, take the derivative, and then just multiply the 1 over r squared. So we're just left with 3 over r squared. That one was pretty easy. So I'm going to take that and I'm going to add it right under its respective expression. And we're going to move on to the E sub theta part. So this part's a little longer. I'm just going to paste it and replace E sub theta with the actual E theta component. There you go. So now we're just going to solve. So since we're actually taking the derivative with respect to theta, we don't care about these other variables like phi or r, so we can just take them out. And so in the front, we're left with sine phi over r squared times sine theta. And I'm also going to take out the 2. And so that just leaves us with sine theta times cosine theta, right? So I'm going to distribute out the sine theta, and we get sine squared theta times cosine theta. And so now we have to take the derivative of this. So I opted to change the sine squared theta into 1 minus cosine squared theta using the trig identity, since I think it was easier to solve that way. You don't have to use the product rule that way. Instead, you have to use a chain rule, which I think is easier. It's not as much writing, I think. So we see that here. We distributed the cosine theta, and now we're just going to take the derivative. So derivative of cosine is just negative sine theta. And then when we're taking the derivative of cosine cube theta, we just use the chain rule, as you can see here. Right. So the last thing we're going to do here is just fix all the signs. Since we have a negative 3 cosine squared theta times a negative sine theta, we end up with a positive right there. So we're going to bring down the constants that we took out before. And we're going to cancel out the sine thetas and rewrite this so that it's easier to visualize. So the last thing we're going to do here is we're just going to distribute the 2 sine phi over r squared. And the reason we're doing this is just so that at the end we're going to be able to combine certain terms. So this just makes it easier to combine those terms. So yeah, we just distribute the 2 sine phi over r squared. And now we're going to put that over here into our expression down here. And we're going to change the color so that we know where that came from. So that came from the e theta component. So it's blue. Lastly, we're going to do the e phi component. So this one's pretty easy as well. We're just going to replace the e sub phi with the actual phi component there. And so again, since we only care about the phi components or the phi variable, we can take everything out. And we're left with sine theta over r squared sine theta. And what we're left with is cosine phi in the derivative. And the sine thetas cancel out. And sine theta, or derivative of cosine phi, is just negative sine phi. So that's what we have here. And we can put that into our expression as well. So next thing we're going to do here is we're just going to simplify this huge equation. So what I'm going to do is I'm going to put this on a different piece of paper so it's easier, or so we have more space. So all the writing that's already present is just me solving the problem initially, so just ignore it. Yeah, I just forgot to erase it. Since they all have the same denominator, I'm just going to erase it and rewrite it as just one term. So that line came out kind of ugly, so I'm rewriting it. Right, so we have some like terms here in the sine phi's. We're going to combine those and get negative 3 sine phi. So what we're going to do now is we're going to start factoring out some terms. So I factored out the 3 sine phi term here, and that leaves us with a negative 1 plus 2 cosine squared theta. And the reason that I did this is so that we can replace the terms inside of the parentheses with a trig identity, since it's actually equals to cosine of 2 theta. It's a double angle identity. So we'll see that right here. There we go. So now we're just going to rewrite this. And next thing we're going to do is we're going to factor out the 3. So we're left with this. And the reason I did this is so that it resembles the actual answer that the book gives us in the problem. So what we're going to do now is we're going to put the what we found for the divergence of the electric field into the initial equation that we created to find the charge density, right? Right, so we're going to replace the divergence of the electric field with the actual divergence that we found here. Right? And so last thing we're going to do is we're just going to distribute the constants, k and e naught, or epsilon naught, and just rewrite it so that it looks nice. There we go. So here we have the answer, and we can check with the book, and we see that's the right one, and it worked out.